Hi guys, we are going to continue talking about volume in the next video and the one after that. Today, this video is going to be talking about finding the volume of composite solids. So finding the volume of a composite solid is very similar to finding like the area of an irregular shape. Volume of a composite solid is where you have a shape that you don't necessarily have a particular formula for that shape. Okay, so what you try to do is split it up into different shapes that you do know how to find the volume of. So if we look at our first shape here, this is called a composite shape. When I look at this, I see two shapes that I do know how to find the volume of. One shape is a cylinder, and the other shape is a cone. So what I'm going to do is I'm going to find the volume of that cylinder. And I know how to do that. Pi r squared h. And then what I'm going to do is I am going to add it to the volume of that cone, which is 1/3 pi r squared h. Okay? And in this particular problem, it does say to leave your answer in terms of pi. Even if it did not say to leave my answer in terms of pi, remember, just like in last week's lessons, this year you are using the pi key whenever you are finding the volume of particular objects. And also, you don't want to hit the pi key until the very, very, very end of the problem. Because if you round in the middle of the problem, it does affect the answer at the end, okay? So you want to hit that pi key at the very end so your answer is as accurate as it could possibly be. Okay, so continuing on with this problem, we're going to find the volume of the cone first. And since I wrote down my formula, now I'm going to plug in what I know. So pi, remember, is just going to stay pi. It's just a regular number. I'm just writing it as a symbol. I know the radius of this cylinder. The radius is 3. So I'm going to substitute that in for my radius. And I know the height of the cylinder is 8.5. So I'm going to plug that in. All right, at this point, I am going to type in everything but the pi portion into my calculator. So I am going to type in 3 squared times 8.5, and I end up with 76.5. And don't round anything. Don't round anything. Sometimes these come up as longer decimals, and you're tempted to round, but you're still not going to round because it's not a final answer. Okay, so 76.5, and now I'm going to attach that pi on. All right, that's only talking about my cylinder. Now I have to find the volume of my cone. So 1/3, pi stays pi. Now the radius is the same radius because that cone and that cylinder share that base shape. So that radius is still 3. And then I'm going to put in my height, and the height of that cone is 4. So when I go to put this in the calculator, I am going to type in 1/3, and then I'm going to do times 3 squared times 4, and I get 12 pi. Well, now I can add the two together. And since I'm leaving my answer in terms of pi, think of pi like an x, like you're combining like terms. I am just going to add 76.5 plus 12, and I get 88.5. Now I can bring down that pi. So 88.5 centimeters, and its volume, so cubed. So the volume of that whole shape is 88.5 pi centimeters cubed. Okay, next example. All right, my next example, it's talking about another irregular shape. I think this one's a little bit easier than the last one. When I look at this, I think, okay, I don't see two objects that I know the formula of, but there's a little hint here. It says that I am finding the volume of a hemisphere, and that is half of a sphere. And I know if I take half of the volume of a sphere, that should give me the volume of a hemisphere. So the volume of a sphere is 4/3 pi r cubed. So I'm going to do half of 4/3 pi, and now I'm going to substitute in my radius. Now, this tells me my diameter is 15. If I know my diameter is 15, I can find my radius by dividing that by 2. So 15 divided by 2, my radius is then going to be 7.5. So I am going to plug in 7.5, and I'm going to cube that. All right, and this one, it says to round to the nearest tenth. So since I am rounding to the nearest tenth, I can put all of this in my calculator. Okay, make sure that this time you do include the pi key. And because now, after I put all that in my calculator, I am getting a final answer, I'm going to say that the volume is approximately, because I'm rounding, 883.6, because I'm rounding to the nearest tenth, kilometers cubed. Okay, one more example. All right, the next example says, Tanya uses a cube-shaped bead with side lengths measuring 12 millimeters. All right, so I'm going to do the best I can and draw a cube. I don't think Mrs. McDonald would be impressed with my drawings, but I try. So a cube, remember, all of the dimensions are the same. So 12 by 12 by 12. Okay, it says each bead has a circular hole in the middle. All right, so if I think about if I'm making a necklace with a bead, there's going to be a hole in it, and it's going to go from one end to the other end. And that makes a cylinder. All right, it says the diameter of the circular hole, because I wrote it kind of small, the diameter is 2 millimeters. All right, since I'm dealing with this cylinder, I know that if I'm finding the volume of something, I am going to cut that diameter in half, because I'm going to need the radius if I'm finding the volume of something. So the radius of this hole that goes through the middle of this bead is actually 1 millimeter. Okay, so this says Tanya uses a cube-shaped bead with side lengths measuring 12 millimeters. Each bead has a circular hole in the middle. The diameter of the circular hole is 2 millimeters. Find the volume of the bead. Okay, so when I look at this, I think the volume of the cube, all three sides are the same, is going to be side cubed. Well, this cylinder hole that's cut out of it is missing. So I'm going to subtract the volume of that cylinder, pi r squared h. Okay, so now I'm going to substitute in what I know. So to find the volume of the actual cube, I'm going to do 12 cubed, and then I'm going to subtract that cylinder that's cut out of it. So pi times the radius, which is 1, times the height, which is 12. All right, so 12 cubed is 1,728. I'm going to subtract, I'm going to put in pi squared times 12, so 12 pi. At this point, I'm ready to find my final answer. So I'm going to type in 1,728 minus 12 pi, and I get 1,690.3 millimeters cubed. Now, the only thing I'm going to change is it's not equals to because I'm rounding it. Remember, anytime you're rounding, it's actually an approximation. So the volume is approximately 1,690.3 millimeters cubed.